Because see, at the end of the day, I told people, if you just got yourself an 80% off bow, find your arrow that you shoot 15 years ago and shoot the arrow over your 166 at 20, 30, and 40 yards. I pretty much will guarantee you the older arrow will penetrate deeper than all your 166.
Really?
Yes, you see, that's something that people don't want to hear.
Welcome to the Deer Gear Podcast. I'm your host, Cameron Derr, and as you just heard, today's guest is again Dorge from Firenock. But today we are also joined by Jeremy Martin from X-Ring Custom Arrows. Jeremy is a certified trained dealer with Firenock, but offers a little bit of a different perspective because he comes as a custom arrow builder. So that's all he does. He is just building arrows to get the best flight possible. In this conversation, it's going to be a two-part podcast. We got kind of cut off by the Great American Outdoor Show starting here at the end of this video. So we're talking about inserts. This episode is going to be 300 OD shaft inserts, 246 inserts, the insert building process. And then on the next episode that you hear from Dorge and Jeremy is going to be 204 OD inserts and 166 inserts, which are really outserts and half outs. So there's a lot to digest in these conversations. Inserts are a huge deal. Building your inserts correctly is an even bigger deal. So you're going to want to pay attention to what these guys have to say. Real quick, before we get into this episode, we still have some amazing savings on the Exodus Render or Exodus Render bundles with the code SHOWTIME on our website, ExodusOutdoorGear.com. You can save 15% off of the Exodus Render or any Exodus Render bundle. So if you're looking to get a cell camera this year, this is a really great time to get your hands on the Exodus Render 4G LTE Verizon certified cell camera. Get it out in the field, test it, make sure you know the ins and outs of that camera before you start to rely on the information from it later on this fall. So with all of that being said, let's hear from Dorge and Jeremy for this week's episode. All right, everyone, welcome to the Great American Outdoor Show here in Harrisburg. It's an exciting time because I'm again joined by Dorge, my arrow expert, and today we have a new guest, Jeremy.
Yes.
Why don't you introduce yourself for everyone that may not know who you are?
All right, I'm Jeremy Martin. I'm from Northeast Ohio, and I own the company X-Ring Custom Arrows, where we build custom arrows using all Firenock components. And just about any shaft you want, we can make them fly just right.
Well, that's why Dorge has you here today. So if you guys haven't already, please go back to some of the previous episodes that we have talked to with Dorge and Dave Murray. If you don't have a good grasp on what happened there before, you probably are going to be lost when we start talking today. So today we're moving on. We're talking about inserts, and this is a topic that I know that Dorge has been really excited to talk about and to finally get to. So, Dorge, take it away.
Well, insert is pretty much the business holding end of the entire arrow. I think let's go back to a little bit of history so people understand what insert is about. Insert is a piece of metal. Very critical. It's a piece of metal that holds the broadhead of field points. That's based on AMO, which now become the ATA standard. Unfortunately, based on the old AMO and ATA standard, the standard ID of the shank of the insert is based on 20245 and 2045 ID. The moment you do that, that means that if you got a tube of an arrow tube, if your arrow tube is say 300,000 or more like 350,000 OD, you're going to have a lot of aluminum before you touch the shank, which is 204,000. Now, in metrics, it's about 5.19 millimeters. That's a lot of metal. Then we also need to understand, like now in the current archery world, I'm going to group them into 5 major groups so people at least got a grab of it. That the O2219 is technically a 350,000 OD shaft, which means that you're looking at about 300,000, which is basically a crossbow size insert. That's pretty much where all the insert original is based on. And as time goes on, people try to make the insert smaller because they like the arrow smaller. As a matter of fact, the smallest actual insert can be put in an arrow is 230 thousandths, which is also, I mean, there's only one company currently making a 230 thousandths ID shaft. Is Black Eagle. I believe that is
The Spartan.
the Spartan. And then the next company make the next size up is 235,000. That's your Eastern XL, Hex, your Michael Waddell. Then the one above it is 245,000, which is your typical, they call it the 7 millimeter shaft from Eastern, and and the rest of the world call it the standard shaft, which is your 242 to 246,000. Then the next one up is your only shaft I know of is the Carbon Express crossbow at 285,000, and then we move to the general 300,000s. And anything above it is anything goes, like your all the major company will make target arrows. Now, just very important that 230,000 is the smallest true insert you can possibly put in it. Why? Because see, when you look at a broadhead based on the standard AMO 832 thread, with the shank that is about 5.2 millimeter, actually it's 5.1945 is the maximum, all the way to about 5 millimeters. Really, people really think about that. That's where all the major problem happens. If you go 202 to 204, that's 2,000ths, okay? And then you put a thread in it. Yes, most people will say the AMO standard say that it's a chamfer on the very end. There's a 45-degree fit on it. That sounds good and dandy, but that 45-degree fit is fit on 202 and 204 shaft. So what's the use of that chamfer? Because at the end of the day, if the tube itself is fit 204, you end up with a gap if you got a 202. Now, when you look at the insert as a whole, it is nothing more than the impact part that holds the broadhead or field point that do not crumble the shaft. But as we know that, I mean, unless the companies are really precise in making the insert itself, ideally it will rub against the inside of the shaft, and then you enough space to put the glue so that the insert and the shaft and the glue will be all straight. Which is also why a lot of people find out the newer modern shaft, the most critical part is that you square the front of your shaft and you glue perfectly the insert on top of it. Now, that's pretty much what the insert usually do. But now, if you really look at more critical part, before we go into the smaller size or bigger size, how do you make the insert concentric with the shaft? That's where most people don't seem to understand how big of that issue that is. Now, I would like to go into a little bit further, talk about the general size first before I go into specific how an insert actually impacts the entire arrow shaft. Now, after you pass 230,000, you're going to deal with the next size down, which is recorded the 202, 204. Now, you remember that number. The 202, 204 is exactly the outside ID of the arrow point 832 shank of your field point and broadhead. Yes, we did say 202, 204. So what happens if your shaft is 202? You try to put a 204 broadhead in it. You're going to get problem. But most places you can do it because you technically crumble the carbon and squeeze it in. Now, one company designed a system that they put the insert inside the arrow shaft and glue it. And then they're using the ID of the shaft to hold the shank. That system sounds okay, but actually there's one major problem with it. Where is the impact end of the insert? Think about it. The impact end is now based on the frontal part of the carbon shaft. Mm-hmm. Carbon is strong, but carbon do not like to be crumbled. And that's exactly what you do. But to make things worse, as we go into concentric issue, imagine the insert is glued into the shaft, right? And if you see your insert tool is nothing more than a pusher, so that the insert is pushed into the shaft in the serpent length, usually about 15 millimeters. Ask yourself this question. If the shaft is indeed 204, the insert cannot be 204. It has to be smaller.
Yeah.
So when you push it in, how do you guarantee that insert is in the center of the shaft?
That's okay.
You couldn't. If you could not guarantee the insert is the center of your shaft, how can you make sure it's concentric? You couldn't. But to make things worse is that when you put glue in it and you push it in, all your glue will be on one side
Yeah.
or on the bottom of one side. Now you've got two issues. You've got a concentric issue, you've got a weight distribution issue. That's the reason a lot of people really find out they don't like the 204 for the long-term use. Then the next shaft down we're dealing with is the 166. People love the 166. But as we already said, the only thing that fit in 166 is the 832 thread of your entire viewpoint, which make insert not a viable condition. So as we talk, brush into every single insert conditions, people understand that insert is not just an insert. Because when people talk insert, we're technically talking anything 245,000 and up, 230,000 and up. How do we overcome this problem? As Jeremy, our Firenock certified and trained dealer, he deal with this problem like everybody else. When you deal with something like the standard size arrow, and people say standard size, we're talking 240,000 all the way to 250,000 ID shaft. Yes, you're dealing with 10,000 now. I mean, yes, most people make the shaft like Carbon Impact make it in 202, Carbon Force 203, your Carbon Express 204, your Black Eagle 205, and your Gold Tip and us and Firenock is 206, 246. So when you make an insert, what size do you make?
There's no universal fit there.
It cannot be universal fit, and that's where the problem is. That means you're using your glue or something else to pick up the gap.
As a filler.
If you fill that gap, how do you guarantee insert is in this center of the shaft? In other words, how do you guarantee insert in the shaft is concentric?
I don't know.
That's where a lot of the, I mean, this is what a lot of arrow builder is. That's the reason most people would look at the insert and say, I want to buy the insert that fit the original size shaft and they will be perfect. But they don't. I mean, a lot of company, like some of the company, they say, oh, I make the 246 size shaft. But before the manufacturing process, the front end of the shaft is closer to 248. Now you got 2,000 play in it. So when you put an insert in it, if our insert is supposed to fit from 242 to 46, and then somebody got a shaft that's 247, you're talking 5,000 slob in it. How do you guarantee the insert sit in the center of the shaft and the glue go around it perfectly? It's close to impossible.
Yeah.
So that's the reason a few things that we have found out look at this as a challenge. Because see, when we do not make shafts, we make inserts. As a matter of fact, we make over 30-something inserts for the entire line. Jeremy was sort of kicking on that and why there is so many. I mean, just like in our 300 size, we make 15 just on the 300 size ID for inserts.
Why?
Because the inserts are different. I mean, first of all, insert is a piece of metal. And all metal have benefit and downside. And of course, we are the guy who invented aero concepts. So in a basic form, first of all, aluminum is not aluminum. Brass is not brass. Stainless is not just stainless. Like in I mean, if you got a chance, since we're doing video, I can point out. This is all 300 size plus 2 more. You can see on a general form, we got brass, stainless steel, aluminum. Brass, stainless steel, aluminum. Brass, stainless, aluminum. Stainless, stainless. But of course, if you do our certified and trained staff, that's another aluminum. See, aluminum is not just 60, 61, and 70, 75. They are not the same material. 60, 61 T6 is a pretty decent aluminum, is aircraft grade. But compared to 70, 75, we're talking about like half the strength. Because the 77 T5 is at 82% strength of a basic 301 stainless, or 303 stainless. But then when you move to something like a 304 stainless, which is more corrosion resistant, which we use a lot in our bow fishing customers, then you move to 420 stainless, which is you can do annealing and hardening. Now you can increase the strength of that insert significantly. But you can also play with how strong it is. Now, unfortunately, we also have, like Jeremy deal with a lot of customers who just they are frugal and penny conscious. And they like the weight of the insert, but they don't want to pay for it. So we also have machine brass. But then you also have to deal with the softness of the brass and the inability to glue of the brass. Because brass, in most cases, easy machining, they're all impregnated. But now, think about it. We're saying that on a 246 size, which is standard, we have an issue with putting the insert in the shaft and be straight. Well, what we come up with a solution. What we call it is reverse tapered, which a lot of people may not understand. Some people love the concept, but they actually do not understand how to use it. Now imagine this. Just like in most cases, the moment you put in, say, you throw a ball bearing into a funnel, and you ask the question, where is the ball bearing? You can pretty much guarantee it's on the dead bottom of the funnel. With that knowledge, would it make sense that we are able, if we throw an insert on top of a shaft, we want it to be dead center? But then we also have to look at it. If you are like me, who have been using archery for a long time and missed the target a few times and shoot into like wood, cinder blocks, and so on, you notice your arrow usually go over the insert.
Yep.
You know what that process is called? It's called the mushrooming.
Okay.
Because your insert actually your shaft mushroomed, and then the insert stick into the shaft. Now that whole process can be mitigated through two methods. In the old days, we say we want to make the longest insert so you got enough gluing surface.
Okay.
But that itself is decent, but not great. Because just like on the previous podcast, we talk about the moment you increase the length of your insert, you also move the node of your arrow backwards. Because at the end of the day, the length of the insert plus your broadhead is the entire true space of the broadhead. So the longer the insert, the further back the node, the more arrow you lose on usage.
Because that's not bending anymore.
Correct. So that was one of the reasons that you notice all Firenock inserts are reasonably short. But then, as a lot of people say, the longer the insert, the more concentric it gets. That's not a true statement. Because what they are talking about is that the longer the insert, the longer the shaft go in, the less angle you can tilt the shaft.
Right.
But that is only a factor of how much play you got the insert in the shaft.
Okay.
The more the variance, the more play you got. But at the end of the day, the more play you got, what they are saying is that the more play you get, the insert can be more off-center with the idea of the shaft. Now, when you do that, I don't care how good the insert is. Just like when you try to hammer a nail and you hammer it at an angle, the insert is going to lose its ability. But that is not the real troublesome idea. It's that your broadhead and field point now is going to hit the shaft at an angle because everything is off-centered. Now, how do you overcome this? We come up with one of our patent on our insert is called the reverse tapered. So what you do is that you find your arrow shaft, and we sell a tool called the arrow chamfering tool. We put a 45-degree taper on the shaft from the inside out.
Okay.
And every Firenock insert that you see on our catalog or from on our product line, at the shoulder of insert, instead of perfectly straight, is reverse tapered. Now, having that said, now imagine this, which means that imagine your shaft is 45-degree chamfered, and your insert got a 45-degree reverse tapered. When you put the two together, you instantly form a mating system.
Yep.
They actually lock into each other. Now, we just talked about mushrooming of the high impact. In this case, when the arrow impact, the arrow is forcing into the center of the shaft. But then a lot of customers, unfortunately, they never learn the process of how to put the insert in. Because see, at the end of the day, if you just put the insert into the glue and you lay the arrow flat on the table,
Well, it's gonna
the
run
insert
more.
is going to go to the bottom of whatever that is. You say, well, then how do you overcome it? That's the reason we do not recommend any of the, fast set glue. You need the glue to set up to the point that you can actually allow it to flow it. Now, this is what they call hydro flow. The whole idea is that you want a glue that is sort of semi-rigid. You can hold the insert on the field point, and you rotate the shaft with it.
Okay.
When you do that process, the glue is now flowing around the shaft because of the hydroflow process. You pretty much guarantee the spacing is going to be exact. But after you do that, which is I consider the most important part, you press down on the shaft. Like the insert end, you press down on the insert end. You now are utilizing the reverse tapered. And when you finish that, you stand your arrow upside down and straight. Because if you don't do that, eventually the glue is going to push down because of gravity towards one side of your shaft. Then your concentrator is out.
And when you say upside down, let's clarify that with the insert should be towards the sky.
Not
Correct.
upside down.
Correct.
Right. The reason for that, because if you don't, if your arrow is not straight, the arrow will go to push down on the shaft and be on one side. You want to mitigate the amount of force that's on the insert after you center it. I hope that makes sense. Now, a lot of people say, hey, why do Firenock on a 300 size make so many different shapes and size and weight of the insert? The reason for that, archery is a very personal sport. I mean, some people want ridiculously like FOC. Some people want heavy. But the fact is that when the time I started archery back in the 1980s, most of the good broadheads are only 100 grain.
Okay.
If you want to put, say, 150 grain in the front, there's no 150 grain good broadheads. How do you do it? Back then, with the 55, 60% off, if you want that 155 grain in the front, the only possible is that you keep on adding either screws or you add a set screws on the back of your insert to make it weight up. But then created concentricity issue, glue issue, loose issue. So we actually make different material in different length, different weight for insert for a specific arrow.
Sure.
So that custom builder like Jeremy, like Dave, or all my actually certified and trained dealers can customize the arrow the way the customer think they want.
Sure.
Because at the end of the day, we can only tell the customer what we think is best. But at the end of the day, they have to decide that.
Right.
Because the archery customers are a very opinionated bunch, and you can't possibly tell them, this won't really work. But they say, this is exactly the way we want it.
Yeah.
We want to make sure that we help them to get their ideal. Unfortunately, sometimes it may not work too well, but this is needed.
Yeah.
And then, of course, when you look at the insert in the case of Firenock, we are the inventor of arrow concept, just like we talked about 2 shows ago. When you have an insert that is a plane, which is just reverse tapered, which is great, you handle all the stuff. But as we move into the higher power arrows, we need the insert to do more, a lot more. And that's where, then for the reason that we at Firenock put certified and trained dealers, is that we want them to able to put arrow concept inserts. The arrow concept insert is a whole different ballgame. As you can holding in your hand, and what I can see here, you can see it's not just an insert, but the insert have a secondary shoulder, which means that people say, why can't they just go ahead and glue a tube behind the insert? Well, if it's that easy, I have already done it. I did it in 2007, 2008. I mean, it works. It absolutely worked. But the problem is that you have to imagine, you put an insert, then you put a tube behind, you glue it. Every time you hit, the insert and the tube will hit each other. And eventually the arrow is going to crack right there where the insert and the glue and the tube is.
Where they meet.
Yeah, because that was the weakest link. Because when you impact, this two materials is going to hit each other head on, internally.
Yep.
So how do you mitigate this? So on our insert, you see there's a second shoulder, is to mount the secondary tubing, which is an arrow concept tube, into the shaft. Just like the way you're holding it. If you can, since we got video, we can show people. See that? That's the insert, that's the shoulder to glue the tube. So now the weakest link between the tube and the shoulder is now gone. Now it's a continuous piece, and you have the carbon tube to prolong it. This is no longer the weakest link, but the strongest link.
Okay.
And people say, why do I have multiple sizes for tubings? Again, it's also choice and also customization of the ability of it. Imagine in the 300 size, we use the Arrow Concept tubing, which is the heavyweight. That's about 8.9 grain per inch, and the lightweight, that's about 6.7 grain per inch. Now you have two different forms. you can use, which means that now you can use different weight and different spine change to the arrow shaft. Now let me give you an idea so you understand how great this insert is when you do this work. If you put a 300 size shaft using a normal insert of ours, using standard insert with arrow concept, say the arrow is 30-inch long, and we go ahead and put the 6-inch tubing in it. Using the heavy weight, you're actually doing, say, the arrow is 30-inch long, we put 6-inch in it. Your effective arrow length is about 25 inches, which means that you now calculate the spine of the shaft no longer by 30, but by 25.
Okay.
But then if you use a lightweight tubing, the total length is whatever the length times 0.6. So that you put a 6-inch in it, you technically minus that length by 3.6 inches. Now your 30-inch is more or less like a 16.4 inches, but 26.4 inches. Now why is that a big deal? Because then you can look at, because at the end of the day, you still need the midsection of that shaft to flex, to handle the power from the arrow. But in some cases, like in the case of like the day when Scorpet was shooting 425, and the only arrow out there is, say, a laser 2, which is a 300 spine. From my calculation, in order to shoot that Scorpet correctly, you're going to need somewhere in the pound 180 spine. Now, that's the reason on those days I actually put in a 10.5-inch shaft inside a 22-inch crossbow arrow. See, very important. You need to understand another thing we have discovered is that the inner shaft, that the insert hole, cannot exceed 45% of the entire arrow shaft, front or back, not front and back. So if you say a 30-inch shaft, the maximum you can put in it is about 12.5 inch in the front and 12.5 inch in the back.
Okay.
But none of them can exceed 45%. Ideally, it's 40. We use 45 to cover it because just in case people want to circumvent our pattern. Ideally, I personally would never go over 40.
What happens if you go longer?
If you go longer, then the arrow no longer flies.
Okay.
Because now you technically break the arrow in half. You're actually causing the arrow to, the tail section is the only section that moves. Because at the end of the day, the arrow will flex in this midsection. At the moment you go beyond that, the arrow is no longer flexing in the midsection anymore. You actually vibrate instead of flex.
Okay.
Because you pass the center point. Just like when you got a guitar string. The moment you put your finger in the middle, or close to the middle of that guitar string, that string no longer function.
Right.
But you can go be a little bit less than that, it will still function. But the moment you pass about 45%, that flex is gone. It defeats the entire reason having an arrow. That actually behaves like a boat. It no longer behaves like an arrow. Then what's the point of having an arrow?
Right.
Is to transition the energy. But at the same time, we want to use the insert, which is part of the, that's the reason the arrow concept carbon tube is part of the insert. Am I helping? Because, I think a lot of people just don't think insert is that complicated of a subject. But it is. Jeremy can also help us in thinking about how by just changing insert, he was able to accomplish some of the impossible build that he did.
Especially with the arrow concept, I know we can probably talk an hour just on arrow concept. But just real briefly, 90% of the guys that you come in contact with are, 28 and a half inch draw. I'm shooting 66 pounds. My carbon to carbon is, 27 and 3/4. Well, you fall, if you look at every single one of the spine chart sheets, you're falling right on the border. Where do you want to go? Do you want to have a finicky arrow on a light spine? Do you want to have a heavy arrow that's going to perform a little better for you, be easier to tune? Well, they say, I want the lighter spine. Now, with the arrow concept, it makes it that much easier. You're kind of like taking that void out of it's going to be finicky. You're still going to have a good flexible, arrow that's going to be lighter, but we add that arrow concept to the front, and then it kind of takes that away, takes the pain away from having a finicky arrow, because we know finicky arrows can be real hard to take care of if you're not
very
meticulous.
Yeah.
Correct. So it builds a lot of forgiveness into the shaft. And also with the arrow concept, it does a myriad of things, from oscillation, cancellation in the shaft, recovery rates, penetration. I mean, the list goes on and on and on, and we can talk
just
about
like
that.
we
But
talked about on the last two show, just by throwing arrow concept in it, even at the basic 16 tubing. I'll be saying, what kind of throw everything at 10.5-inch tubing, with the especially with your arrow insert H. See, the word H in our standard is that you got a reverse taper on the front and you got a double shoulder on the back.
Okay.
That's the reason it's called the H. The H have both functions.
Yeah.
We call it the hybrid. For people who just don't want to work with too much, we make the arrow insert A. A means that it's angled, it's reverse tapered. But the beauty of this is that now, imagine just like Jeremy say, a guy really want the bow, say a 60-pound guy, 26-inch draw, he should be in the 400 spine. Okay, there's no doubt about it. But he may want to shoot a heavier insert or heavier field points or insert. He say, no, I'm more like, you see, some company make 150 grain point I really want to use with the broadhead. Now you got a problem.
Yep.
Because the 400 spine is no longer valid, isn't it? But then if the moment you add, he say that, but I will not go with 150. So now you go ahead and throw a 6-inch lightweight tubing in it. You effectively...
which is what you're holding there.
Yep,
Is the lightweight.
you effectively added minus about 3.6 inch off the shaft. Say that 26-inch shaft now will behave more like a 24.4 inch shaft.
So it stiffens it up.
It not just stiffens it up, because this is the only thing about people stiffen up. But when you are dealing with a 400 spine shaft, do you know that if you ever touch the arrow in the front after you shoot an animal, being a 400 spine is very, very brittle, because the wall thickness is not there, not like the
Super
basic 300.
Sure.
But the moment you use that insert and you throw arrow concept tubing on it, as I said, you are just adding about close to 0.7 to 0.9 millimeter to the thickness of that wall, plus the ability of the glue, which is a shock absorbing. Because remember, we talked about in last two shows, that the AGUSSE is not just a epoxy. It also a shock absorbing compound and allow two separate material to pull against each other. If they can pull it, that means they have this flexible. Anytime you know it's flexible, it behaves like a shock, absorber to the impact. As you imagine, if you put a shorter insert of metal part into the arrow, you are getting a longer section of the arrow being exposed to damage. But the moment you put an arrow concept tube in it, you just change the whole thing upside down, isn't it?
Yeah.
But then that itself is not as important as what most people who now, everybody think I want to shoot heavyweight in the front. I want the front of center to increase. The arrow concept gives you a heavier front of center, but it's the distributed front of center, not a focal point. But on top of that, you also elongated your node. Because see, when you shoot say a heavy FOC in the front, your node is actually more and more pronounced. That means your arrow become even less and less forgiving. That means if your arrow is slightly off the node and you launch it, your broadhead launch angle will increase significantly, which means that the chance of that broadhead catching wind is higher. And because of the heavy FOC, with the node being so pronounced, the weak point from that node onwards is also pronounced significantly. By using the correct insert with the arrow concept, all those things that we talk about, is, if not eliminated, is significantly mitigated. But all we're talking about is basically your 300, 246. The moment you go below that into like the 204 and the 166, this whole insert become a whole different ballgame. Because you cannot possibly, some company using the idea of a shaft to hold the shank of the insert, but then the back, the neck of your field point and broadhead become the crushing point of your shaft. We at Firenock do not believe that is a right way to do it. We believe that back then when a few other companies like Trophy Ridge, they all make half out, which I was involved with. I think that's the way to go. Because at that moment, when they say half out, means that half the insert is outside the shaft and half the inside the shaft. I think that's the best approach. Then using everything we talk about insert in the 300, the 246, now actually apply to the 204.
Okay.
And on top of that, see, this is where in the 204 class, the insert actually become a lot more knowledge involved. As a lot of my dealer will tell you, the first time they do my 204, they just glue the thing together thinking it's like a 300 and 246. Because the insert and the OD or the shaft are very similar, they sort of can get away laying the shaft on the table. But that in a 204 class, it is absolutely not possible. Because the very, very end of the 204, as you can see on this end, that's 8 millimeter. And 204 OD is average, is 5 millimeters.
Okay.
That means the moment when you put this thing on the table,
It's going to be like this.
you see there's a gap there.
Sure.
And the moment you lay it on the table, your insert is going to do this. You are cockeyed. I mean, Jeremy, one of the guys who actually took the time, just like I said, put the insert in, spin, hydro spin the shaft, and then get it all the way you need. Now, and people say, well, 204, most companies have one insert. The Firenock, we have 9 times technically infinite, as you can see right here. The basic insert, I mean, the basic chamfer insert, I got it in aluminum, that's a 7071, stainless steel, and titanium. People say, are you crazy? Why would you need titanium? Because, see, we want to teach the customer how low FOC is important for the thinner the shaft, the lower the FOC is important.
Okay.
And people think the reverse,
Yeah.
which is unfortunate. I mean, just like, Jeremy had one of the few guys who built ridiculous arrow with low FOC, arrow concept on both sides for customer like 45-pound pull, 26-inch draw. I mean, every time I talk about customer about that, I would always bring Jeremy's build up. I mean, the gentleman will call him, how much is your draw length? 26-inch. What's your draw weight? I can work up to 45 pounds. and he did the wonderful job for him.
So how does that guy gets exponential performance compared to his old setup?
Oh, absolutely.
What's that do? What's that do when the guy can then pull 70 pounds and his draw length's a little bit longer? Is it even more exponential, or is it kind of the same translation?
It's about the same translation,
Yeah.
but the fact is that you get a lot more out of it.
Sure.
Because see, imagine this, it is not how many, I think in most cases a lot of people forgot. And just like a lot of customers call me, I got a 20-inch draw, I can't shoot anything unless I put an 80-pound bow. I say no, because I need about 80-pound KE to kill the animal. The fact remains that if you have a well-designed broadhead, if you have the arrows flying correctly, you do not need more than 25 pounds of KE to blow through a North American whitetail.
Okay.
Even if the sucker is 350 pounds,
Yeah.
which most people will never see in their life. The problem is not how much energy you put in.
It's how much you retain.
How
It's
much
how much
it retains.
Yeah.
Retained and on the impact point.
Sure.
And a lot of people do not understand just because you say, oh my God, my energy, they will send me a picture of the chronograph of the arrow going at 60 yards. They say, this is the speed I'm going in. Then I will tell them, at that specific speed, at that specific point, is your arrow straight.
Okay. Has
That
it
means
recovered?
the position of your blade towards the target is a bigger deal than your speed.
Yeah.
I will repeat that one more time. The point of impact, the angle of impact to your field point and broadhead at the target point, at the specific speed. The speed and the weight is not as important as the position and the angle of the arrow itself to the target.
Sure. That makes sense.
Do you know the difference in extreme cases? It's over 30%.
Wow.
That means
30% loss.
correct, or 30% gain.
Sure. Yeah.
That means that you may be, in the case of, say, you're shooting a 80-pound bow with a 500-grain arrow, and you should get about, 85 KE. Assuming you don't lose anything at a specific distance, the moment your arrow is hitting the target at, say, 5 degrees off, which is not much, but most people never thought, oh, how can it be? Okay, let's mine it to 3 degrees. Which you can pretty much assume it will if you shoot a high FOC arrow. that 80-pound KE you got,
It's 50.
you just lost 30% of it.
That's significant.
Yes. You think about it. You have 56-pound KE final. Just on that concept. We are not talking about parabolic action loss. We're not talking about drag loss. We are not talking about a micro vibration of aero flight. Assuming all of them are not lost because of due to heavy FOC. At that moment, your 80-pound KE become 56-pound KE.
Yeah, that's what I was gonna add that in too, because I was gonna say, well, if you only need 25, what's it matter? But then you have all those other factors that you're gonna lose KE as well.
But then now imagine the arrow he built for that customer. There's barely 300 grains something, but the arrow is going in absolutely perfectly straight.
Mm-hmm.
The arrow recovered in less than 5 or 6 feet because it got Aero Concept 2.0 in it. That arrow lose less than 8% energy at 60 yards. So that 45-pound KE, I would just go for 10%. You still got 41 pounds of KE in your hand. That's the reason it shoot through the elk like was nothing. I mean, the easiest way for everybody to think through this is that imagine this: you got a tomato in your hand, okay? Don't cut, and then hold a very sharp knife, perpendicularly cut it. You know you're going to need some force to break the skin and down, right?
Yeah. Yep.
Now, slide that knife 2 or 3. Then just go with 3 degrees, and do the same force going down.
Press a
If
little
you
harder.
use less than 30% force on it, you're lucky.
Yeah.
What does that mean? That just pretty much proved what we just said.
Right.
But now you add to the fact is that you have your hand holding the knife. The moment your arrow is hitting that and the thing is not straight, everything behind the field point is now doing all kind of weird things. The vector of the force is now all off center.
Because it's still trying to become straight. It's trying to
Correct.
correct itself.
But if it's not straight when you hit it, all the angle is going to off. Your number just like keep going down, 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 down.
Sure.
But then people say, oh, wow, if I got enough momentum. Well, it's all true if you're holding a hammer.
Yeah.
But you're not. I mean, it's even quite true if you're holding an axe. But now you don't hold anything.
Yeah.
The whole thing is based on the long cycle after effect of the bow shooting, which is where the insert come into play. Because see, there's another thing, a myth I want to bust. Oh, after I build the arrow, I try to put everything together, I put the insert in front of the thing, and it was off. And you know what the guys told me? They got to square the insert on the squaring device. Let's sit back and think about it. The fact is that your insert is machined. The absolute top is flat.
Yeah.
Now you glue the insert into your shaft, and it was cockeyed. And you're going to square the insert to flat. What happened to the thread inside?
Yeah, it was already square.
It's already cockeyed.
Yeah,
and then
yeah.
when you put your broadhead, that square on it, you're just forcing your broadhead and your insert to be off.
To be misaligned.
Yeah.
Yes, misaligned. That's even better. And what happened when you impact?
Oh, it's gonna break.
It's not going to break. The force is automatically be off.
Yeah.
Remember, the moment you're off, just like all your geometry will kick in. When you're off by 30 degrees, how much? I mean, just like your geometry, your tangent, your tangent, your cosine and sine, you notice that the moment you're not hitting straight, the force is not just reduced because it is not a bullet. It is an arrow. The rest of the arrow is coming too.
Sure.
I mean, yes, if you have a heavy FOC arrow, all the force in the front, but at the end of the day, you still have your shaft, your vein, and your nock. They all have a certain mass in it,
Just wait. Yeah.
which is weight. And the longer the arrow flexes, the worse the insert is going to able to mitigate it.
Okay.
So that's the reason the concentricity of the insert and the flatness of the insert after you put in the shaft is so critical. And of course, Aero Concept helped. But then if you understand all this, which is why people, the moment they move from the 246 into the 202, the problem compound. The moment they move into the 166, can 166 use inserts? Answer is no. 166 is technically a full out.
Yeah.
You know what the word full out means? That the entire broadhead from the
on the
thread
outside.
up is in front of the shaft. Because see, the only thing that can be inside the 166 is the thread part. But if the thread part is the only part that can be inside the shaft, where's the transition? There's no transition. So metal must be in the shaft first.
Yeah.
And then go a transition to the bottom of the thing. So your entire, from field point to the insert to the end of the insert, the entire unit become your final length
Yeah,
of
that
your arrow.
extends your arrow size.
Now, how do you overcome this? The answer is outserts. Or you rethink what the process is. But based on the AMO's ATA standard, you cannot do that because 832 is the minimum size of all broadhead and field points, unless you change that. A company did do that. I mean, like Eastern, they did the Deep 6.
Yeah.
They make everything smaller. But if you look at the American engineering book, 440 over 832. The 440 do not even hold 30% ability of the 832.
Wow.
I mean, the only other way is increase material, but then we also have to deal with the moment the girth is one of the most important part of all material.
Yeah.
So I think I didn't want to go into the 166 because there's a whole deal, or even go any 2364. But I think in this video, the most important part I think people take away is don't try to square your insert. You need a concentric install the insert. Hydroflow your insert when you install them. At the same time, try to square your arrow the first. Squaring is the minimum you can do to help you the most. Chamfering is the right way to do it. I mean, anything beyond that, you're dealing with like anything over, say, your 285, 300, or below your 204, so on. That's a whole different subject because every single size have a different set of problems.
Sure.
So when people say, when you look at Firenock, say, hey, you got over, what, close to 40 inserts? If you look at my outsert, that's over 60. When you look at target stuff, it's over 90 now. That is that many. You know why? Because it's just like every single size
It's all
have a
different.
specific problem.
Sure.
And that is, in that reason, every single size with a specific problem needs specific solutions. Which is unfortunate that a lot of people don't take into think, oh, I just jumped one size smaller. The set of problem you face by jumping one size or two size smaller is so significantly more than just simply say, I'm changing the material. Because the entire geometry, physical design, and mechanical design is totally different. And I just don't want to brush on it. Is that when you deal with the 166, you cannot use insert. You have to use full outsert, or you have a full half out, or a full outsert.
Sure.
And in the number of, we were very happy that this year, 2021, we granted the last two patent. Is how we actually bypass all the 832 stuff and design a stem system to deal with the 166 to mitigate all the problems. I think I will leave that for next
That's
show.
exciting, yeah.
Because see, I want to talk about 240, 204, and 166 on its own. Because see, that itself has so much more problem in it that need to be addressed.
Would you say that's currently the most popular size people
Oh,
come
absolutely.
to you?
Just because it's popular and most people don't understand it.
Sure.
See, when people don't understand something, there's only two reactions. It's the greatest thing because I don't understand it.
Yeah.
It is the worst thing because I don't understand it.
Sure.
So the truth is somewhere between.
Yep.
The people who understand it, and just like a lot of customers come to me and say, hey, I understand the beauty of 166, but I can't find the right shaft. Those are the guys who understand what 166 does. But most people don't.
Yeah, I think that's something that I think it's just all marketing. That's kind of.
I think it's more like
confusing
more like myth more than
people.
anything.
Yeah.
Marketing, at least in some cases, I got a marketing degree. Marketing is trying to sell people what you have found out and promote them to buy.
Yeah.
I would say myth and some what I consider lies. You are selling something that didn't work because most people don't understand.
Sure. Yeah.
Now that I was totally against.
Yeah. It's like they're marketing things that they don't understand.
Yes, that is what in my limited mind I would consider lying.
Sure. Yeah. Sure. Yeah. They are lying to you. That's I mean, I'm that guy. You know what I mean? I'm the guy that came in. I was like, I got to shoot a 166 arrow. I have to shoot. Why? Why do you need a 166? Because it penetrates more. That's what That's what everyone tells you. You have a thinner diameter shaft that penetrates better. And I never asked why. I never was like, oh, how's that possible? I just like, okay, that's what it is. That's
That'll
what
work.
they told me. Yep.
Right.
So, and then I talked to you, and you talk about how, like, if you have your broadhead is a certain size and you have a 166 arrow, it doesn't even touch anything when it goes through. So there,
Since you don't touch anything, you will go deeper.
yeah, there's
No,
no
it does
drag.
not.
Yeah,
Right.
yeah. That's going to be. This is kind of some good foreshadowing into the next episode, because I don't know anyone that currently shoots a 246 or a 300. So all the people that are listening to this are going to be like, man, I got to hear that 166 204 conversation.
Well, just
the
give an idea.
166 is definitely. It was 204 was pretty much the hot topic for the past 4 years, 5 years. This last year, the 166 is like completely want to fly off the shelf.
Yep.
Now, the Western guys, they've always been a 166 fan. I've got a few to switch over to 204. Not very many guys want to go to the 246, but the 204 is, I like to say, it's the great medium between, obviously it is the medium between the 166 and 246. But the options are endless.
What do you think people's biggest holdup going to a 246 is? Why do you think people won't go to that?
They lose penetration, and honestly, it's not the fad.
It's not sexy.
Hunting is, or the hunting industry seems to be very fad oriented.
Sure.
You
can't
gotta
agree
have
more.
That's true.
You've got to have the Sitka gear. You got to have the first light. You've got to have this. You've got to have that.
Sure.
All of it's great, but you're looked at in a different light if you don't have that, which is kind of, I don't like it because
Right,
I like
yeah.
being different.
Yeah. and
So
at the end of the day, it just needs to work.
yes, I want efficiency.
Yep.
I don't care what it looks like as long as it goes.
Yeah, I think that's huge, because like I'm 100. I'm that guy, right?
Right.
And I 100% look at that arrow. I'm like 246 or 300. It's like that thing's
Yeah.
that doesn't look cool.
Look old school.
Yeah.
Let me give you a hint. This year, I have 4 customers. 2021, I have 4 customers that I know for a long time that I personally build arrows with. You know what size I use?
300.
Every one of them is 300. Yes, we're talking gold tip 22 size, 300 ID, 400 spine, arrow concept for 60-pound guy, 65-pound guy, and 70-pound guy. And when they go to the range and shoot with the 80% and especially the 90% evil guy,
Yeah.
side by side, say, Dorge, what's going on with this shaft? It looks so old-fashioned.
Yeah. Yeah.
It looked like what my dad have used.
Yep.
But they work.
They actually work so beautifully. Because see, at the end of the day, I told people, if you just got yourself an 80% loud bow, find your arrow that you shoot 15 years ago and shoot the arrow over your 166 at 20, 30, and 40 yards. I pretty much will guarantee you the older arrow will penetrate deeper than all your 166.
Really?
Yes, you see, that's something that people don't want to hear.
No, it's not. It's not. What
But the
I wanna
fact
hear.
is
It's
that-
definitely not, because it loses all of its. It has to work so hard to get going, to get flat and flying the way they're supposed to. It's all that energy is being sucked up by the shaft because it's such a heavy wall, and people. I don't know if they don't want to understand it and say, yeah, whatever,
Yeah.
or they can't
grasp
comprehend
it.
that the wall thickness takes energy, more energy than a 246 or a 300.
That's the thing people need to understand from hearing this. But
Absolutely.
the show here is starting, so
We'll
we're going to
wrap
get
it up.
kicked out of here.
We're
but,
going to cut it
yeah.
cut it off quick.
Yeah, well, stay tuned for the next episode, guys, because it's going to be a banger. But we'll see you next time.
Thanks, guys.